All right, let's start off on the first 6 here. They're determining whether it's 1 to 1, so that is really the horizontal line test. It works the same as the vertical line test. If it hits more than once, then it is a fail. So on number 2 here, I would say that this one is a pass. So number 2 is yes, because none of those lines hit more than once. You may be a little concerned about this flat part right there, but I really don't. It really doesn't. It's got to like curve back up in order for this to be a fail. Because it's really only flat for that one instant. All right, so the number 4 I'm going to say is no. That horizontal line does hit and really an infinite number of times, so that would not be. Number 6, however, would be because none of those hit more than once. All right, next up here, we're going to do number 20. And so they say with this function, we want to find g inverse of 5. Now, normally this is an x value, but when we have inverse, x and y are switched. So that's actually a y value. So what I'm going to do is I'm going to take this function, plug in 5 right there, and here we go. And now we're going to get one side to 0 since this is a quadratic, and we're going to go ahead and solve it. So I'll factor it. What do we got here? We got a plus 5 and a minus 1. So x equals negative 5, x equals positive 1. However, they did make this note here that x must be greater than or equal to negative 2. And so I'm going to exclude that one and just say that 1 is our answer on that. All right, next up, this set, we're going to find the inverse function. So I'm going to start off with 38 here. And so the first step for all inverse functions is switch x and y. And so I'm going to put here x equals y minus 2 over y plus 2. Our next step then is to isolate y. So I'm actually going to multiply this y plus 2 over to the other side. I'm going to go ahead and cancel this out. I'll distribute that in. So I get xy plus 2x equals y minus 2. Now in this case, it's kind of weird to isolate y because we have 2 of them. So what I'm going to do is I'm going to get everything with a y on one side, I'll do the left, and then everything without a y on the other side. So I'm going to subtract the 2x over here. So this will be xy minus y equals negative 2x minus 2. Oh, I subtracted 2x, not 2, okay. And now I'm going to GCF a y, and I get x minus 1, and then we get negative 2x minus 2. We'll divide both sides by x minus 1. And so then I'm done. They do want us to always write your answer, switch your y, and to call it f inverse of x since it was based on kind of the inverse of an old function. So there you go. Now a quick note on this. Sometimes this will be written with every single sign switched. It's really, if you want to think of it like they multiply the top and the bottom by negative 1. This is just another alternative way to write that answer. So either one of these answers is correct. So always keep that in mind. All right, next up, number 40. So on this one, once again, I'm going to switch x and y. So x equals 5 minus 4y to the third. So now I need to isolate y, so I'm going to subtract 5 from each side. So x minus 5 equals negative 4y to the third. Now I'm going to divide the whole thing by negative 4. I think they'll usually throw the negative out front of the whole fraction here, so it applies to either the top or the bottom, but not really both. And there you go. And then that last step would be to cube root it to get rid of the cubed. Now, we do not put a plus or minus when we do a cube root. It's really only for even roots. And so you know what? I'm just going to name this right now f inverse of x, since I have y isolated, is the cube root of negative x minus 5 all over 4. All right, next up here, number 74 and 75. So we have the demand function given the price. And so here is our demand, and then P is the price. Now, if we find D inverse, what that would actually represent, or actually, let's find it first. And so we're going to switch X and Y. It's not X and Y, though. I actually don't want to switch kind of the names of the variables here. I'm just going to keep them as is. And so I'm just going to isolate the other variable. So I'm going to isolate P. So then I'm going to say D, the demand the demand minus 150 equals, let's see, negative 3P. And then we're going to divide the whole thing by negative 3. And then P equals D minus 150 all over negative 3. And so I would say D inverse equals D minus 150 all over negative 3. Now, I liked not switching the variables here because they actually do represent, and this will help us like with what it represents. This actually does represent price, okay? So we've kind of solved for the other variable. So it gives you the price if given the demand. So it just kind of switches this around. So then D inverse of 30 would be me actually plugging in a 30 in for the demand. So that would be negative 120 over negative 3. So that would be a price of 40. So if the demand is 30, if demand is 30, price is 40. So it's just the original function was solving for demand if you knew price. Now we're solving for price if you know demand. Shout out to Mr. Hughes and his econ class for teaching us so much about that. So you guys try 75. Like I said, on these word problems, it's kind of, I'd say it's not that good to switch the names of the variables, but just solve for the other variable.